Hello, kids. You're in for a treat today. It is the area of a regular polygon with me, Mr. Adam, and I am approaching this as a Montessori teacher, as a human being, as someone who is exploring this with you. So please, please, kids, understand I'm trying to reach you where you are. I have tried to watch as many videos as I can in preparation for this, and I'm going to do the best I can, but I'm going to teach you how I'm figuring this out. And let's hope that you guys are with me. So the first thing I'm going to do is I'm going to tell you I am not going to do any trigonometry with angles to try to figure out side lengths for any of these triangles we're going to be looking at with these polygons. I am only going to be doing a very basic presentation on how to find the area of a regular polygon when you get the side length and the length of the apothem or apothegm. There were different pronunciations. I apologize, I'm going to probably use both, apothem or apothegm, and I have to get there first. So, whoop, forget you, let's talk about triangles first, because really when I was researching this whole thing here, I was like, how am I going to teach the area of a regular polygon? I wanted to first talk about the basics of how we're going to do this. So the first thing is we just want to review the area of a triangle. And so I drew a nice ugly triangle there for you with a base of 7 and a height of 6. If you look up there, my formula is 1/2 base times height. That is the area of a triangle formula. And I went ahead and did 1/2 times 6 times 7. That got me 42 over 2. That got me 21 units squared. We always have to give our answer in units squared when we are doing area. So the area of a triangle is very important for understanding the area of any other polygon, because what I found when I was researching this is you have to find what's called the apothem or the apothegm, which is different than a radius, and it's like this line that would bisect a triangle inside of a polygon. So I'll talk about that in a minute. I do want to show you this triangle here. So I've got my beautiful triangle, geometry cabinet triangle. Sorry about the missing little knob there. But I want to find the area of this triangle. So what do? Well, first of all, let me show you that I've got a version of this triangle that is already cut in half. So put this on here for you. So I've got a triangle here. I've got the same triangle, except for now you see the line here. The line there in that triangle is the height, right? And the base is the bottom part here. It's the base. So we've got the height and the base, and I've got a little trusty ruler here. I'm not going to do this for the polygon as much, but I am going to do this for this triangle. So I'm going to go ahead and measure the base. Let's do this in centimeters. Apologies to those of you that love the English American system. And I get a length here of about 10 centimeters. So that's my base. And I'm going to pull this out, kind of cheat a little bit, and go for my height here. See how I'm going to measure my height here in centimeters. And my height is about 8.5 centimeters. So you guys can't really see that, but let me do my best to show you. Sorry that I should have used a different ruler now that I realize this. But that's about 8.5, and the base here looks about 10. Say about 10 centimeters there. Okay, let's see if I can lower it so you can see that. There you go, over the rug. So, well, got my triangle, and I said I had a height of, what did I say, 8.5? Let's double check. Yeah, 8.5. That was my height. So the formula is 1/2 base times height. area equals 1/2. My base was 10 centimeters. My height was 8.5. Okay, so there's what I have so far. All right, so 1/2 base times height. So 10 times 8.5 is 85 over 2. Area equals 85 over 2 units squared. I can go ahead and do my division here. 85 divided by 2, 4, 0, 5, 2, minus 4, 1. 42.5, 42.5. So the area of this triangle that I just found is 42.5 centimeters squared. So why am I doing this review? Most of you are already well familiar with how to find the area of a triangle. Well, this is incredibly important when we look at the area of a regular polygon. First, some definitions. So let's talk about our friend Mr. Pentagon here. He's fun, he's interesting, he's great. But look at him. He's got certain things that we need to know. So let me just define a couple of these things for you. The first thing we have to look at is the fact that this is a regular polygon. So I'm going to write that down. It's a regular polygon, not irregular. It's a regular polygon. And if you notice, this pentagon, which is 5-sided, is a regular polygon because all of the sides are the same length. And a side, as you can see, is the distance from one vertex to the other. And that's another thing you need to know, vertex. Right? The vertex is like a point here. So all of these are what are called vertices. Okay? I'm trying to do this. There you go. Oh, much better. So you have all the sides are the same length. Okay. And the sides are all the same length. What this also means, kids, is do you see these angles here? Let me draw on this real quick. Do you see what I drew there? A little angle line? That means that all of these angles are also all the same. Pretty cool. And that is really interesting because if the sides are all the same, the angles are all the same. So those are angles and those are sides. And I think you guys already know what is called when you add up the length of all the sides. If you add up the length of all the sides here, you get what is called the perimeter. That's right. And let's see, I gave you perimeter, and I gave you vertex. Okay, plural vertices. So there's just some things you need to know about a regular polygon. The sides are all the same length, the angles are the same. It has the perimeter, and it has the points called the vertex, and one is called a vertex, and then they're called vertices if they're plural. There's many more things. For example here, one cool thing I learned is that do you see the angles there? Well, what are the angle measurements there? Well, what I learned was that a great way to find that out is I've got a pentagon here divided. You have all the radius lines drawn, which are drawn from the vertices to the midpoint in the center there. That's the midpoint there. And it was really cool because I saw this video where the woman drew, see those angle lines there? If I pull each of these out, I've got 1, 2, 3, 4, 1/5 of the total angle measure. Well, that's interesting because we know the total angle measure of a circle. Look at the circle, right? It's a circle. What's the total angle measure of a circle? It's 360 degrees. If I have 1/5 of that, I know what this little angle there is. That's really cool. And if I know that little angle, I can also find the other angle down here, but not just of the one. I can find that full angle there. How do I do that? Well, this was really cool seeing this. So first of all, let me do some math. Gonna have to erase my work here. So if I've got that middle one there, so again, 360 degrees, but I only want one, right? And so I'm going to do 360 divided by 5. Find that angle measure. 7, 2. Okay, so I found that that angle there is 72 degrees. And isn't this cool and interesting? What I realized is that I take that 72 degrees, and if I look at it, let me take out all of these guys real quick. Ooh, this thing's kind of dirty. So sorry. If I took that 72 degrees and I put it up against there like that, I could find the rest of that angle. And the rest of that angle would be, well, what's a straight angle, kids? I think you know. Straight angle is 180 degrees. So it's 180 minus 72, which gives us an angle measure on the inside there of 108 degrees. So each of those angles there, if those other ones are all 72, then those are all 108. That's really cool. I thought that was really interesting. It's even more interesting that I'm drawing on the Montessori pieces with the dry erase marker. This is probably some sort of something bad that I'm doing here, but it's all in the name of teaching the children, so I don't care. All right, so I have got proof that all my angles are the same. Down here, all the angles up there from the midpoint are all the same. So we, in fact, do have a regular polygon here, this pentagon. So I thought that was a little cool, but I am getting sidetracked here a little bit. So let's go back to how do we find the area of this pentagon here. All right, so here we go. I have my pentagon, and I have my pentagon divided into these triangles. That is, in fact, the first step to finding the area of a polygon, is to draw those triangles. Okay. So I've got my friendly polygon here. And what you do, what I'm going to do here, is I'm going to be a little tricky here. I had trouble earlier finding the midpoint, and I realized it was because I wasn't being smart. Because we're going to assume that we have the given midpoint here. Some things we're just going to have to assume that we have. Okay, so I've got that there. So my midpoint's right around there. Thank you. So I've got my midpoint right about there, okay? And what I need to do is draw my lines here. Do my best. I tried finding a black small marker, but ended up raiding Miss Carol's cabinet and finding a green one instead. Sorry, Miss Carol. Just is what it is. Okay. Looking what I have there. That's pretty good, actually. I drew my lines. Okay. And now I'm going to show you this thing called apothem or apothem. So do you see how I have each of these triangles here? Just like these. See how I have each of these triangles? Well, if you look at the bottom one, I'm going to hold up one of these triangles here. We've got this triangle here, which matches this one here. Right? And what makes this triangle any different than this triangle? Well, obviously they're not the same, but they are both triangles. So doesn't it stand to reason that we can find the area of one of these triangles on this pentagon here, this regular polygon? Doesn't it stand to reason that we could find the area of one of these triangles and then multiply it by 5 to get, why 5, Mr. Adam? Well, 5 triangles, 1, 2, 3, 4, 5. Doesn't it stand to reason that we could do that? Yes, it does. So my job is to find the area of one of these triangles. Now, this is important, kids, because this is where you are I'm going to give you a given. I was watching some videos where they can solve for this only knowing angle measurements using trigonometry. I'm not doing any of that. What I'm going to do is draw a line in between here, bisecting this triangle here, bisecting this line. This line here is incredibly important. This line is called the apothem / apothum. That line, that's an A, by the way, not an I. That line is called the apothem. And the apothem, as you can see, those two little lines show that those two are the same length. It basically bisects that line. And oh my lord, exact same thing that we did here, because what I just did was I have the height of a triangle. I have the height of a triangle. If I know the side length of my triangle, and let's say the side length is 5 centimeters, it's longer than that. I'm not going to do exact measurements here, but I'm going to at least make it 6. Okay. So if I'm going to have a side length of 6 centimeters, okay, and oh, I can't believe I'm doing this. This is a bad idea, but nobody ever accused me of not pursuing bad ideas. And let's say the apothem is 4, okay, centimeters. Guess what? I can find the area of that triangle. I'm going to outline this in blue now. I can find the area of that triangle because I have the side length and I have the height of the triangle, which is the same as the apothem there. So what am I going to do? Boom-bitty boom. 6 and 4. Let's do 1/2 base times height. 1/2 6 times 4 is 24 over 2 equals 12 centimeters squared. So the area of that triangle is 12 centimeters squared, the blue one that I just made. Okay, 1/2 base times height. Now, what do I do to find the area of the entire pentagon? Well, what do you think? Don't we just multiply it by 5? Yeah, because that's how many sides there are. There are 1, 2, 3, 4, 5 sides to this polygon. So, times 5 equals 60 centimeters squared. So I just found the area of my pentagon by essentially making it into a smaller problem and doing what I know, which is the area of a triangle. Because the apothem is the height of that triangle and 6 is the base, and there you go. So I have my area of my pentagon here. So, well, unfortunately, it's not that simple. Well, it kind of is. But there is a special formula that they do have for this. So this is sort of my original, what I was going to work with originally. And there's the apothem, and there's the triangle part there. You see that? Okay. Well, the formula for finding the area of a regular polygon, not just a pentagon, any regular polygon, could be a hexagon, etc., is 1/2 apothem times perimeter. And perimeter, right, is the number of sides, right? So you have the side length times the number of sides. So my side length for this one was 6, and I would multiply that by 5. So what I did was I did that at the end to show you the triangle, but the formula is 1/2 apothem or apothem times the perimeter. That is the formula for the area of a regular polygon. And your units, it's going to be equals units squared, whatever those units are going to be, units squared. So let's have some fun. Let's experiment a little bit here. So we know that we have to do something that's a regular polygon. Irregular polygons, definitely not going to work. Totally different way of going about it. But I thought that I would have a little fun here. I found, in Miss Carol's work, I found this lovely volume hexagon here. 1, 2, 3, 4, 5, 6-sided figure. So I thought it would be great if we could use this as an example, not to find volume. We're only going to find the area, or in this case, the surface area of this side here. So let me erase our beautiful work here and go about the same thing. So what I'm going to do, I'm going to trace it first. All right, here we go. Because like I said, this works for any regular polygon. All right, so there I have my hexagon. Okay. Yay. All right, so how am I going to find the area? Well, we've got to have a midpoint. Okay, and my midpoint, this could be bad, but I think that looks pretty good as a midpoint. And we have to know the length of the sides. So this is probably a bad idea, but I will end up adjusting. Looks like each side is going to be 6 centimeters. All right, so what do I do? Well, let's first draw our triangles the way we're supposed to. We're going to draw the number of triangles that we need. 1, 2, 3. Ooh, this one, I could have kept these lines going because apparently this one's easier than a pentagon. Mr. Collin told me that. He was like, Adam, if you're going to do this, the hexagon is easier. I was like, I'm good. Well, he was right, as usual, when it comes to this stuff. But I did my very best. Look what I have there. Okay, oh, here we go. All right, so I got my hexagon. All right, so each side is 6. And now I have to go ahead and draw my apothem. And again, we are going to find the area of a regular polygon given the apothem and given the length of the sides. Okay, we're not going to do angle measures yet. We're not going to do anything difficult yet. We just have to get this area formula. So, I'm going to draw my apothem here. There's my apothem. See how I drew my apothem there? All right, so my apothem, the length is 5. This is actually working out for me. Thank God. All right, so the apothem is 5 centimeters. And what I'm going to do again is show you that finding the area of a regular polygon, that is a polygon with all the same side lengths and all the same angles, right? The angles here are the same. The angles here are the same. Okay, regular polygon. The formula is 1/2 A times P. Well, let's go ahead and test that theory because I'm going to go back and double check with my, I'm going to be honest with you guys, I'm going to go back and double check with my triangle work, but I'm going to try it. We'll see if this works. All right, 1/2 area, or apothem times perimeter. So that is the area of a regular polygon. Let's test it out here. All right, so I have an side length of 6, but I cannot use 6 because that's only one side. I have to have the whole perimeter. But if the sides are all the same length, 6 times 1, 2, 3, 4, 5, 6, that gives me a perimeter of 36. Okay, sorry, started there. And the apothem is 5. Okay, I want you guys to see how I did that. Okay, 1, 2, 3, 4, 5, 6. So that's 6, 12, 18, 24, 30, 36. And the apothem, you see it there, is 5. So I've got my perimeter as 36 and my apothem as 5. Well, let's go for it. What's 36 times 5? 30, 180 over 2. 1/2 of 180 is 90. 90 centimeters squared is the area of my regular hexagon here. Well, let's do it. I feel more comfortable checking my work by seeing if I can find the triangle area and then multiplying by 6. So I am going to erase another one here. I want to double check my work because I don't trust things and I may have made a mistake. So let's double check here. Triangle 1/2 base times height. I'm going to do this triangle. So 6 times 5. 1/2. 6 times 5. 1/2, 6 times 5. Because my height is the same as the apothem, which is 5, and my base there is 6 of the blue triangle. So 1/2, 6 times 5, so that's 30 over 2 is 15. Okay, 15 centimeters squared is the area of this triangle. So 15 centimeters squared is the area of that blue triangle there that I made on the hexagon. But I have to multiply that by the number of triangles that I have. So that's times 6. So 15 times 6 is 90. Yes. Was there doubt in my mind? Yeah, there was. So the area of my regular polygon, my hexagon, is 90 centimeters squared, just like I had by doing it with the formula. So it looks like we can trust this formula. Sorry, formula. I'm not a very trusting man, especially with stuff that is new to me. So I want to make sure. So I got 90 centimeters squared. Put the line about this one for both of them for my hexagon. So, yay! So kids, now you should be able to find the area of a regular polygon because you have the formula. And to review, the formula is the area equals 1/2 apothem times perimeter. So that is what I want you to take away from this. I also want you to take away that it really is about breaking your polygon down into smaller triangles. And that is how I wrapped my head around this, and I hope you learned something from this and had a little fun along the way. I know I did. I had no idea coming into this past week how I was going to do this presentation, and I decided that I would have some fun and meet you where I am with this, and I'm always exploring and trying to learn new things. This has been great for me. I hope you learned a little something. I look forward to our presentation this week, and have a great day. Bye.